So now that we're out on site, I mean, I'm hearing a lot of sounds, there's a lot of cars, a lot of distractions, right? And this is my first time on a construction site, so I know safety is our #1 priority. And we talked about it in the office, but man, it's different out here, right?
It is.
I mean, it feels different. So could you maybe remind me of some of the core things I need to make sure I'm careful of, maybe some rookie mistakes if you can think of any, just to make sure that we can all stay safe while we're out here?
Sure. Safety is #1, like I said before, and you kind of want to have your head on a swivel. So
Okay.
as I'm talking to you, I'm still listening. I noticed a beeping noise. I noticed traffic stopped right here. It's going fast over there. These are just things that I've learned to process without really thinking about it. Now, you never can get complacent with safety. You always have to check yourself. So the most important thing I feel like you have on right now, since we're not actually doing any construction, is your vest. Lots of traffic, reflective vests, you need them. They need to be able to see you, and you need to be able to see them, of course, with your head being on a swivel. The other thing is the eye protection. So eye protection is real important. You want to be able to have glasses that are rated to withstand blast or different things like that. So, and you definitely don't want, when you're hammering, say you're trying to put a control point in the ground and you're hitting the iron rod, there's shards that can come off and hit you in your glasses. Hit you in your eye. If you don't have your glasses, it could be bad. Also, the last thing, well, one of the last things I think is the hard hat. Now, it's kind of silly sometimes thinking, why would I have a hard hat? Why do I have a hard hat? I'm not on a machine. I'm not near a machine. Well, the hard hat is just an extra safety precaution, just in case. So there's could be things falling. There could be tons of things that could damage your skull. The other thing is you want to have boots. So either have steel toe are good. They're ideal. You don't necessarily need steel toe in this situation, but leather bound boots are great, right? So any sort of like oil or spills or concrete, there's different chemical components that are in the concrete that you don't want on your skin that can burn and irritate. So yeah, and long sleeve, you're actually doing better than I am, because I have short sleeves on and you have long sleeve. Obviously sun protection, right? So it's March, I think I can soak it in, but reality is you should have long sleeves. Jeans, need jeans. So jeans or any durable pants wear. So you don't want to wear slacks or anything like that. Anything that can rip or snag easily. You want something durable and tough.
And then in terms of rookie mistakes, I mean, I've got all this PPE on, but I've still got to follow traffic rules. I still should probably cross at a proper place and not think that I'm invincible, right?
Right.
Would that be considered a rookie mistake, thinking, hey, I've got this on, clearly they see me?
Yes. So you want to abide by all the laws and regulations that come with being in the city limits, right? And plus it's safety, right? Mm-hmm. So yeah, so we did construct crosswalks for a reason, right? So we have a working one here, so why not use it?
So tell me where we're at and what we're looking at behind us.
So what we were looking at earlier in the office was they had this construction project on Everhart. So this is Everhart Road right here, and this is obvious our construction from all the barrels that we have going on and the noises. You notice there's a lot of traffic. There's a lot of distractions. I'm constantly, even as I'm talking, I'm looking around and I'm checking things and I'm making sure everything is going to go as planned, right? So our plan was, when we got here, was to do a film session of kind of what we do as surveyors and control points and getting the job started. So that's why I wanted to bring you here out in the field to kind of show you what it feels like, right? To kind of get the jitters off you. It takes a little while to get acclimated to this sort of situation, because it can be a little high intensity, especially with a lot of the pedestrians and the time of day. So we're at Everhart and Staples. Now over here, we've completed a lot of our widening on. This is our full reconstruction right here. So basically all this is done, but we can't open it up yet because we still have stuff to do, and there's a lot of traffic control plans that we have to adhere to, and we have to complete the rest of this roadway before we can start switching people over. And also in the intersection, we've completed that as well. So all that is new construction. Now I'll show you kind of the limits of our project if you'd like.
Sure.
And if you come over this way, you can see where the asphalt meets the concrete, right? And then you see that other patch of asphalt right there. So you can kind of see the different color schemes. So this is the limits of our project. So these are limits. And we've constructed all this, like I said, we constructed everything down there. We've even done the sidewalk and what we call a retaining curb. We have all that built. And if you'd like, we can go on site and take a few looks at the survey truck.
That'd be great. Let's go take a look at the
All right.
survey truck, yeah. All right, Zach, so I see that we're here next to one of JE's survey trucks. So could you give us a quick tour of maybe some of the equipment you have with you and what's in the bed of the truck as well?
Yeah, sure. So I guess I'll start with the cool stuff, the expensive stuff. So we have our robotic system right here. So this is the SPS 980. You can go ahead and lift it up. Now this is our robotic total station. And this does a lot of the hard work for us.
Nice.
There's a prism. Now this is a 360 target prism, which you'll have on the rod once you get your total station up and going. We have a actual base station here. We don't have it set up at the time, but of course you have all your components that go in with having a base station. And of course there's a pole that this sits on. All right, if y'all want to just make your way around here to the back of the truck, we'll see what this guy's got. All right, materials, water. Number one here in South Texas, you're gonna need to be hydrated. That is a for real. Ice, keep it cool.
Lots of ice, yeah, nice.
Also, since we were talking about our instruments earlier, I'll go ahead and cover this right here. So this is our tripod that we use to set our total station on top of.
Okay.
We really want a nice tripod because we don't want that expensive equipment getting dinged up. We have our bipod. Now this will be connected to your rod and you'll be able to stake out points, and sometimes you can remove them if need be. We have our survey rod, which this is Andy right here. Andy is our surveyor, and he is staking out to one of our control points that we'll go look at later. And we always want to make sure we got the right measurement, right? So always need it on the right measurement, because you set your total station up and you're on the wrong measurement and everything starts looking good, there could be some problems. All right. Some of the other equipment that y'all are probably more familiar with is going to be our spray paint. We'll have an assortment of different colors. We typically try to use blue for water. We'll use orange for typical construction, and pink is kind of an alternative. You'll see some clear coat there. That's just to make the writing last longer or the paint last longer. Here's our laths with our lath bag. We use 3-foot laths, which we'll write grades or whatever we're staking out. We'll be able to identify it by using a lath and marker. Other stuff, boots, of course. It does get dirty. Here's one of our, this is just a piece of rebar, but what we can use this for is a control point. So we can actually put a cap on here. We can hammer this all the way down into the ground, make sure it's steady, and put a point on top, and we can create a point, control point out of this. All right. Hammers, shovels. Now, this is what we try not to use because there could be a lot of labor involved, but typically, well, I would say before my time, these were used quite often. So you would have to blue top. What we call blue top is just putting hubs in the ground at a grade that a piece of equipment needs to cut to. So we'll set the blue tops or the hubs at a certain elevation to wherever we need the material layer to be to. That would be our grade. So say that if we leave a little bit of our, here's our hubs. I'll show you 1 second. It's our hub bag. So this is our hubs. And you can see why we call them blue tops, because they got a little blue top. Now this is just so you can identify it and you can see it with all the material getting covered on top of it. So we'll drive this thing in the ground. If we're not running machine control, or if there's a small driveway that we need to do, we'll have to set it at a certain grade, and we'll use blue tops in order for the operator to know what elevation to cut the ground to. All right.
So you've got a lot in the back of the truck. So I'm assuming there's like an equipment list you guys would use, or really kind of a standard loadout. Is there anything that you occasionally would bring to the job site, or is it pretty standard loadout for most of your construction projects?
Well, it's a standard loadout, right? So they want to be fully prepared no matter what their task is at hand. So if they have because there can always be last minute things that come up. You never don't want to be prepared, because that's going to cost you time, it costs your company money. You always want to make sure you have extra batteries. That's a huge one. You want to make sure you have a means of charging those batteries. You want to make sure that you have all the wood, the material that you need for the day, if not for the week. So typically what they do, we'll have a surveyor, and he'll have an assistant, and his assistant will make sure that we have all the materials that are needed for that day or that week. And he'll load it up, he'll take an inventory, usually on Mondays, and see how much inventory is needed. And he'll get back with me, of course, if there's insufficient amounts of material.
Okay, great. So I know we've got the GPS rover set up, so I think we're gonna go stake out a control point and see what that looks like on the site.
Correct, will do.
Let's do it.
All right.
All right, Zach, so I know in the office we talked about the control points that we have all around the construction site. And so we're standing at one now. So can you talk about a little bit about what equipment we have here, how you established it or found it, and then what does this paint mean on the ground?
Oh, okay, yeah. Well, what we have here is we got our Trimble GPS system. We're using a VRS network, which is approved by the state of Texas.
And so VRS, Virtual Reference System, I believe.
Yes.
And that's in lieu of using our own base station if you had set that up on site?
Yeah, correct. So there's advantages and disadvantages of both. For this particular site, we have a clear advantage of using our VRS system, just because we have a lot of power lines out here. We have a lot of obstructions, and to set up a base station and really get good reception, we have a lot of chances that we won't be able to pick it up.
Okay.
But yeah, it's just ideal for it. It can be a preference too, so you don't necessarily need one, you got to have one of them. But you can choose one over the other. Mm-hmm. But for quick and easy, VRS makes it really simple to just turn on, jump out of your truck, your survey truck, and go to a point. Mm-hmm. Whereas a base station, you would set it up on a control point, leave it up there all day, and possibly take it down after you're done with the work. So there's a lot more time cut out. Now the base station can be more accurate than the VRS, but here VRS has been getting a lot better over the years, so we're really kind of leaning on this.
Well, that's good to know that you have the options, you can make the choice, and the good news is we have the modern technology to make our lives easier, but also maintain that accuracy that we need, right?
Right.
And so we have the GPS unit. We're clearly over the control point that we saw in the office. So tell me more about who set that, how did you find it, and then tell me about the spray paint.
Sure. So this control point wasn't set by us. In fact, sometimes you can look down there, and you could possibly see some indicators of who it was before. And fortunately, we have an indicator. We have Urban Engineering, CC, Texas. So that tells me Urban Engineering, it's a local engineering firm around here. They set this control point. So if I ever had any disputes about the control or needed to ask any questions, I could get a hold of them. I like this control point because it was set by others and verified by us. So we know this is a good control point. Now, it depends on kind of where you put control points. Like, you'll notice that this is in between a joint of the concrete. So it's not like ideal. I wouldn't come back in 5 years and think that that'll be okay. You'll see monuments like TxDOT where they'll actually have a brass monument, and they'll put concrete around it or something. They'll preserve it better. They'll do it on bridges. If you go to some of these bridges around Corpus Christi, or around Nueces County, you'll notice that there's monuments actually in the handrails or the railing. So they'll put them in the concrete, in the railing, because we all know that bridge isn't supposed to move, you know, at least making your way up to the bridge, which is the approach or the abutment. Mm-hmm. So, I'm sorry, but I was gonna go ahead and cover the paint as well. So this is obviously freshly painted, and we had Andy here, and he went ahead and just marked it, and what I just call it as lit it up. So he went ahead and lit up that control point. Now this certain type of paint, it breaks down really quickly. So it's not your typical spray paint that you may see, graffiti or whatnot. So this type of water-based solution, it breaks down pretty easy. So in about 6 months, it'll be white, almost not even noticeable. So that's why we like to use that paint, even though it's real loud. We want it to be loud, but we don't want it to last.
And so I see CP134, so I'm assuming that's the identifier. But tell me about what Andy painted underneath. I have E25.07, so what is that telling me?
Yeah, sure. So the elevation is critical with what we're doing. So you can reference a lot of things in this job site for, say, horizontal or bearing, or you can match. You can measure off a lot of things horizontally, but the very difficult thing to do is to figure out what everything is doing vertically, because you have a bunch of vertical, you know, structures where you can come off of and understand that there is a vertical point on a structure, but you really don't know that elevation. You don't know how to break down that math. Like, I don't know the height of that structure right there. I could only be guessing. Whereas a tape measure, I could probably pull and tell you the width of that sidewalk. Well, it's just vertical is a lot more difficult to figure out. And the reason why I say that is anybody could come up here, they could use this as, say, a benchmark. So not only is it a control point for all of our horizontal location, it also gives us our vertical elevation. So we have CP control point 134 provided by urban engineering with that at an elevation of 25.07. And that's of course off of our vertical datum system or whatever that is in the area that we're referencing.
Sure. Oh, thank you. Yeah. So next time I'm walking down the sidewalk near a construction site and I see these, I mean, you know, being a surveyor, I'm always looking for brass tops and, you know, and these nails, right?
Right.
But seeing that ring around the nail, okay, now I know I've got an identifier, so that's pretty cool to see who's been in the area. And now I know a little bit more about what you're painting on the side, so I can say, oh, that's one of their control points. I see E, that's elevation, so that's really kind of cool to know. But then also, I know that since we are doing a road, you know, it's all elevation, right?
Right.
And so it makes sense that that is besides what that is, the most important part is very likely the elevation.
Correct. And I can go into elevation a little bit more, not being a surveyor, and if I was, say, constructing a pipe underneath the roadway, I would need to know which flow line to put that pipe at. So I also need to know the grade of that pipe in which to drain to the next inlet, because all this storm water has to go somewhere. So it goes in your curb inlets and you forget about it.
Right.
But there's usually a point on wherever you're at where there's an outfall. And the main outfall, I believe, is in Nueces Bay, over here near downtown, where all the storm drain goes to. So you definitely don't want your flow line to be lower than your adjacent storm structures, unless you want the water there. Because the water doesn't lie. The water's always going to tell you where you're at. If you're low, you're high.
All right. Okay, thank you. So after this, I think we're going to go now across the street and look at some of the unfinished part of the road, as well as some machine control. So I'm really excited to look at that. So shall we walk over and take a look?
Sure, I'll show you the way.
Okay, let's do it.
Come on.
All right. All right, Zach, so as we've been walking around the construction site, I'm seeing a lot of lath. I'm seeing a lot of spray paint, right? So I wanted to pause and say, you know, so there's a lath, and I can see the blue top underneath it, but what are you writing on this lath? Why is it so important that everything's written on these lath? It looks like that's a kind of a different language for you guys.
Yeah, so it's not like land surveying, as you would know. The information on here is for everyone. So it's for the people, it's for us, it's for the people constructing. So we want to give them a lot of, not too much information, but just enough information in order to construct the work. We also have the flagging on it just so you can identify it from far away. Because you notice there's a lot going on in here. You got a lot of rubble, and also we don't want it to get hit, right? So there's valuable information. It costs money for us to come out here and put this in here, so we want to make sure it lasts. So as far as what would I have Andy here doing is he's staking out to, what do you have there, Andy?
Edge of pavement.
He's staking out to our edge of pavement and
3 foot offset edge pavement.
top of pavement.
And so,
all right,
so you're saying 3 foot offset top of pavement, right? So on the lath, I'm seeing TP, so I'm assuming top of pavement,
Correct.
right? And then 3 foot offset, you're doing that because if you were on the pavement, well, they got to put the pavement on your reference, which would destroy it, right? So you do a lot of offsetting, it sounds like, to say, hey, this is the 3 foot top, but I need you 3 feet that way so I can maintain my stake. Is that correct?
That's correct, exactly. So we generally offset everything, right? Because we have to construct there, and it would be in the way if we put it at the edge of pavement. If we were to just put a stake on line, it would get eliminated completely. Sometimes we do that just so you have a visual of where things are. So if they needed to know, hey, just tell me where my edge of pavement is. Okay, I can do that. I'll give you a stake at edge. That'll be fine. But we want something to kind of last here, and we're going to put a lot of information on the stake if necessary. So we want to offset this stake, and 3 foot is a good number for the paving. Now that we could do an offset of 15 feet, and that would be a good number for something underground, right? So they're creating a large divot, a big hole, so we need a further offset for that. Now, as you alluded to earlier, we have a DNS 23.95 TP, so top of paving, that's what that tells me. And this is actually a design elevation. So I have a design elevation telling me how far it is to the top of paving. Now it might be a little confusing at first trying to read these laths and understand exactly what they mean, and I kind of take it for granted and just expect people to know sometimes. But there's also more information on the front, but the hub itself is set, like I said earlier, the blue top is at elevation. So we have it at a set elevation. Now it might be random, but we want to let whoever's reading the stake know what elevation that we have it at, or what the fill is to that elevation. This design elevation is for the paving itself. So if they were to open up their plan sheets, they were to say, hey, I kind of know where I'm at. There's my design elevation to my top of paving. I can look at my plan sheets and be like, oh, I'm near a radius on a driveway. My elevation should be somewhere in the ballpark of 23.95.
Okay, so just to make sure I'm understanding, right? So that is my design top of pavement. So when all this construction is done, that is, we're at the top of that hub is where Everhart's going to be.
Exactly.
3 feet that way, right?
Exactly.
Because this is the offset. Okay, that's making a lot of sense in terms of, how I can read that and say, okay, design, that's where I'm at, 3 feet that way, I maintain my control, right? So hopefully it doesn't get destroyed.
Yes.
And then now I also understand why you have the blue tops, the whiskers on the blue top, because there's going to be dirt on top of it, and there's no way I could ever find that hub in that ground unless there was something sticking up to where I could identify it. And then of course we have the lath that also says, hey, there's a hub nearby, so I have really 2 ways to identify it.
Right, Rick, you're bringing it all home. So notice the control point that we had earlier with the elevation that was written on it. So that's an actual elevation. You can technically call it design, but that's our actual elevation. I want to make sure that you know the difference. So this isn't our actual elevation of the hub itself. This is the elevation that we need to get to. So if I were to set up a tripod and have an auto level, and I could backsite that control point over there with a Philly rod, get my elevation, know my instrument height, and I could bring that Philly rod and set it on top of this point, I could then calculate how much fill is necessary in order to achieve that elevation.
Understood. Great. So, so we've got the location. So obviously we have a GPS, so we have our X and Y, and we have our Z, we have our design elevation, we have our control points. So I can see where it's all starting to fit together a little bit, right? And as we have the control points, I can see all these lath coming up and down here. So there's just a lot of information out in the open so that everybody can see it. Because I imagine you don't want anything hidden at any time, or you don't want to say, oh man, the design sheet's way over there in my truck, right? So at least you have a quick reference or something that's like on the ground.
You do.
That's really neat.
And there's more to this stake, Rick. I was going to show you the other side.
Oh, I didn't even think of the other side. There's a lot more on it.
So on the other side, it actually tells us our 3-foot offset. And then it also identifies that there's a driveway and then there's a stop. Now this tells me that we have a driveway coming in right beside us, and that there's a stop happening right here. So at this hub, 3 feet in, this driveway ties in to that driveway, which is down there. This tells me this is the stop or start of the driveway.
And okay, and then the last is, you know, I see a FT, so I see TP, top of pavement, I know that. And is that a F plus, or is that a station? What's that something 44 there?
Yeah, great question. So that's actually a fill.
A fill,
so
okay.
We know now to come up in elevation to achieve what our design elevation is.
Okay, from the hub.
From the
blue
hub.
top, okay. Great, so we know the design elevation, which we can check against our control point. Am I good so far?
We can check, yeah, well, we can check our elevation of our hub by using our control point.
Okay, and then we know that from that hub, the blue top, I need to fill, how much are we seeing there?
0.44.
0.44 feet.
Yes.
Above that is where we need to be.
For our top of pavement.
For top of pavement, okay.
Finished grade.
Excellent.
That's it. So
thank you.
More with this stake, you can do a lot of things, right? So we talked about the driveway, we talked about the finished grade of the paving itself. We know where the edge is. There's also one more thing. It also can tell me, and we can interpret a lot of things from this. So if we know that our paving is, call it 1 foot for easy math, if our paving is 1 foot thick and we got to go up 0.44 to get to the top of that paving, then that's telling me we have to go down 0.56 to get to the bottom of the paving, which in turn is the top of our next material layer that we construct.
Okay, great. So I'm understanding the lath a little bit more, and we've definitely thrown some terms around. So I think what would be good for us to do next is to maybe take a look at what's happening behind us, really explain like what are the different levels. And so let's maybe find another vantage point and start talking about what we're seeing behind us and bring it all together that way.
Sounds good.
All right, Zach, so I'm seeing a lot of layers here as we're constructing a road. So you kind of walk me through what I'm looking at and how a surveyor helps this get built.
Yeah, sure. So this is a really good example of the layering that I was talking about before. Now, or material layer is what I referred to. So right now we're standing on what we call subgrade. This is pretty close to where we need it, judging by how the blade and the machine controller are cutting right now. So this is pretty good. What's going to happen is they're going to put a lime solution, possibly, maybe not for this project, correct me, but either a lime solution and they'll mix it in to make it harder or sustain more weight. I believe in this project though that this is sufficient. It was already engineered that this will hold all of these layers and there won't be too many imperfections or inconsistencies in the material.
Okay, so this is rough grade that we're standing on.
Rough grade.
Now, is there anything underneath rough grade, or is this kind of the first like scrape?
That's it. This is as far down as we need to go for this project.
Okay, excellent.
All right, and what we have on top of this is this was already constructed, so it's not like it's a saw cut of an old roadway. We're actually tying in all of our construction into this corner, so this edge. So this edge just so happens it's our center line, which is our alignment, and which has a PGL associated with it. So this alignment is a good place for our crown. So we also, not only is it our PGL It's also our alignment. It's our center line. You can call it our baseline, and it's our crown. So it can get real confusing when people are referring to center lines. But most of the time, the people that will use the term that this is our crown, right? So out in the field, with a lot of the construction workers here, we'll just refer to it as a crown of the road. So this is the crown, which is the breaking point where everything breaks to the side for water.
Right, yeah, because I'm definitely seeing a grade going that way, so assuming it's going to be draining this way.
That's right.
And then also, I know center line and land surveying, we do a lot of pulls to center line because it's a really stable reference point for us. So it's interesting to see that we also have the same concept in construction surveying as well. It's a really important piece of the job site.
Very important. In fact, this is the most important.
Okay.
But when you come into actually constructing the roadway after we get our control set, which is, you have to have your control right for anything else to be right, correct? So the next thing that comes after setting our control points is getting our alignment correct. So we have to make sure that we have our northing easting on our start of our alignment. We have to make sure if there's any horizontal breaks in that alignment that they're accounted for. And we also have to make that we have that vertical curvature or those vertical breaks in the PGL or the crown.
Okay. And so we have the crown, we've got the subgrade. So tell me, so now I know I'm at the base, so let's work our way up to get to top of pavement, right?
Right. So this is bottom of base, top of subgrade. And then here we have a material called base, which is really just cement and crushed up concrete. A lot of this concrete that we're demoing out here actually gets recycled and crushed, and then we add some chemical components to it, and then we're able to get it wet so it can harden, and then we'll call this base. So this, you can put a lot, we're just building up to our finished grade product, which is this concrete. And of course it's a thickness of, I believe, 9 inches, and you can always measure that. So right after our base, our top of base, bottom of concrete, that's when we come into our finished product. And this is kind of the bread and butter. This is what everyone sees. This is what you want to get right aesthetically. So you want to make sure that after, a lot of things can happen and go wrong. You don't want things to go wrong, but this is the cherry on top. So you'll really want to put a lot of focus on this, on finishing this concrete.
All right, so then just to recap, we have, so we're standing on
Subgrade.
Subgrade, I already forgot. And then we have base on top of that,
That's
bottom
right.
of concrete. And then we have top of pavement, or in this case, concrete.
Right.
Okay, great. And then, so then when we have the design elevation, that was to the top of pavement. So that's
right.
The concrete in this case, okay. And then we can really kind of work our way down from that, because if we know top of pavement, thickness of base, right? We're kind of, you can work our way up and down relative to our elevation.
You're ready to work.
Great. I'll put in my job application. Let's do it.
We'll push you through the line.
Okay, I'll take it. All right, Zach, so we're standing in front of a really big piece of equipment. Looks really cool. I know I already see the word Trimble, so I know there's something survey related going on, but can you explain what is this piece of equipment? What's it used for? I'm assuming it's cutting some kind of grade.
Right.
And how does surveying link to this?
That is a strange phenomenon.
Okay.
And that just kind of happened all at once. So generally when you have a motor, this is a motor grader. So we use this to kind of do our final grading. This is kind of the stuff you think about when you're a little kid or you give a little boy a little Tonka toy. Well, this is kind of it, right? But in live form. So what we have here is a motor grader. This kind of does the fine-tuning cuts on the material layers that we need before the concrete. So he'll be cutting his subgrade, which we talked about in here, and then also once this is finished subgrade, then we'll go ahead and start dropping that base, which is all that crushed concrete and cement. And then he'll go ahead and grade that out. And of course, there's a certain thickness to that. So what this does is this saves our back, because we're not having to put in blue tops like I told you. Traditionally we would use a sledgehammer. Now we do have to do it, and people like to see it sometimes, but We eliminates blue tops, which is, you know, a grid that we would put elevations at about every 25 feet in order for him to cut to. But he doesn't have to worry about that because he has all this on his screen inside of his cab. So this big thing right here is our mast. This is a hydraulic mast. This is made by Trimble, and on the top of it, it has a prism. So that prism is linked to a robot, which is the robotic system, the total station, and it's actually reading wherever he moves. It knows exactly where he's moving at any time. He knows exactly what grade he's at any time. Now there are things that can go wrong, but I won't get into that. But yeah, he can actually move his mast up and down if he needs to, and it'll still give him grade right here at the bottom of his blade. So he told me just now that he's roughed in, he's pretty good, so this should be about it. It made sense because we looked at the center line or the alignment over there, and we noticed the material layers, and we should be pretty close to grade here. Another thing I wanted to mention is he does have a screen inside of his cab. Now that also has a file in it, a CAD file. I don't want to get too deep into all the software that we use and all the components that come with it, but just know that it has a design with a surface design in it, also line strings, DXF, in which he can follow. So essentially, it's just like that controller that we have, that TSC7, but it's in his cab. So, but there's a lot of little things he can do. He can tilt it, he can move it, he can do. There's probably stuff on here that a lot of us don't even know about.
Sure, so now it's really making sense to me, right? So we have the control point, we have our elevations, right? We've got our offsets, the blue tops, but normally I would assume in the old days, we would have a lot of blue tops he would be going back and forth over and basically just trying to skim that blue top hub.
That's right.
Right, which, I mean, that's, I can't imagine the skill it takes to do that, right?
It does.
And so a lot of skill in terms of driving the equipment, understanding what's going on. But what's neat now is since we have the robotic total station, and we've got the reflector, you can do stakeless grading, right? So that's really neat that we can have the precision and the technology to do that, to make, you know, the operator's life easy. You know, still a lot of skill in terms of everything you said, figuring out the angles and stuff I know nothing about, but I can see where it's coming together. So we know where that is in relation to the motor grader, in relation to our control point, in relation to our robot. Am I getting that right?
You're getting it all right. Okay. It all comes together.
Very good.
And like I said earlier, I wanted to go back on how this phenomenon happened, right? So surveyors were always good with their equipment. They were coming up with these skill sets and using robotic total stations, and technology was advancing pretty fast using GPS and base stations. Well, someone had the bright idea of, hey, let's just put it on a machine. And who's better to figure this stuff out than a surveyor? So it just so happens, how the cards fell, that the survey departments in our industry have a lot to do with what's going on with these grading systems.
Very cool.
And you can outfit a dozer, you can outfit an excavator, so this isn't, or a skidster, this isn't the sole thing that can actually use this robotic total station or the GPS system.
Nice. All right, so I think next up we're maybe going to take a quick look inside the cab just to see what that might look like, but then also I know we want to walk over to the robotic total station just to see what's staring at this thing, and then I bet it's sitting over a control point or some known location within elevation, right?
It does know its location and elevation.
Okay, well let's take a little further look around.
Okay, sounds good.
All right.
You usually want to keep about 15 feet away from the back of it. Y'all can stay up here. But what I wanted to talk about was, if you noticed, we have that pink paint again. Oh, I see. Remember our other control point that we had an elevation? So right here we have an elevation as well. So what he's doing is he's benching into this elevation just to make sure everything's right. Everything's clicking. He knows 24.26 or 96. 2496? Why? Oh, it's all right. So he has to bench in here make sure he's reading it right in order to go ahead and begin grading again, because he doesn't want to be off cut and grade and then have to come and put more back or take some away. All right. Okay, go ahead.
Okay, so we were just at the motor grader behind you, and you said it referenced a robotic total station, which we have here. So can you talk about, why did you set this up here, and then just the interaction between the robotic total station and the motor grader?
Sure. The easy answer is we set this up here to be out of the way.
Okay.
And we don't want it in the parking lot. There's a lot of rules to setting up a total station. You generally don't want to put it in asphalt, because sometimes the asphalt, when it gets hot, and gets squishy. We chose this spot because it's more outside of the construction zone, and also we can see 2 control points. So this total station knows exactly where it's at and at what elevation.
Okay, so so again, control, it all comes together, right?
Oh, it all
points.
control.
Yeah, exactly, all the control. And then with the robotic total station, this is doing what with the motor grader exactly? So hitting that reflector, and that's then triangulating the elevation, is that correct?
Yeah, so first off, we did the triangulation with our resection, is what we call it. So we did a resection off 2 known control points. So we know they're northing, they're easting, their elevation. So if anything in survey, right, if you know 2 points, you can get location and distance, and you can start figuring out a lot of math with 2 points. That's all we need. We just need those 2 points, and once we do, we backsite both of those. It does we call it a resection. It goes ahead, it does its calculation, and it gives us corrections. So it tells us, hey, you're out of tolerance on horizontal, you might need to reshoot it, or your control point may have moved, or it says, hey, you're out of tolerance on vertical. So this total station is really smart. It takes a lot of the math out of it and really kind of dumbs it down. You just got to know what you're working with and how to treat it right, and know what you're reading. So it does require a lot of kind of skill set, understanding where to put it, how to put it up, the control that you're using. But in turn, it takes away a lot of the hard math that you sometimes have to do. But you do have to revert to a lot of it. But this does take a lot of the triangulation math out of the equation.
Okay, great. Well, yeah, thanks for explaining how it works together, right? I mean, it's, nowadays you think everything is GPS, right? But when it comes down to, I mean, you're working to the hundredths in some cases,
yes,
right? And you're not going to get that vertically with the GNSS. So that's why we're using these total stations and the reflectors.
Exactly.
Yeah, and so I think it's just a really important part to really acknowledge, is that there's still a lot of usage, because we need, it's amazing what you're working to out here. That's amazing, right? But it requires this high-tech stuff. So it's really cool, and I really appreciate you showing this to us.
Yeah, certainly. It is amazing that we want to get it that close too. All this chaos that you see out here, then you get a finished product, and you want to be real tight on that.
Yeah.
I was going to add a few things about the total station before we break away. Now that once we get the total station, the resection done, so just like a surveyor would with his controller and his rod with his prism, he can go stake out or check elevations or whatever he needs to do. The motor grader can essentially do the same thing. So it has its own prism, it knows its own elevation, just like we talked before. So he could, on his model, he could actually tell me where the elevation sits at, or where the edge of pavement is located, or an assortment of things on his models. So it's almost like he's an operator, but in a sense, he's a surveyor too.
Very cool.
And I just want to thank you for your time and finding interest in this subject, because it's a lot of information, and a lot of people don't ask these questions that you're asking. And in our industry, it's usually you just have to figure it out as you go. So there's not a real structure, learning structure for all this. It's if you want to learn it, you'll learn it. If you don't, you won't.
Right. Well, no, I appreciate that, right? And I also appreciate JE Construction Services and you having us out to the construction site and really helping us expose the craft and the skill and the knowledge and the planning that really goes into something that I mean, look at all the citizens that are using this work, right? I mean, there's got to be a level of satisfaction that you have coming through thinking about, man, I'm materially affecting lives as a construction surveyor, right? And as a construction company. And I think it's really fascinating, and I know we appreciate it when we're driving on it, but even I had no idea how much it takes. You know, it's really impressive, and I appreciate, again, you guys allowing us to come out and learn a little bit about how you work.
Sure, not a problem.
All right.
All right, appreciate it.
Yep,
Thank
absolutely.
you, Rick.
Thanks.
Thanks.
Lucky you guys with that.
There's